Let's get started. Welcome everyone to our webinar, Streamlining Landing Factors in ForeFlight. Today we will demonstrate ForeFlight's new Landing Factor Selector within ForeFlight's Runway Analysis. Landing Factor Selector enhances operational efficiency and minimizes risk by replacing repetitive and error-prone manual data entry with convenient automations based on manufacturer source performance data. Let's meet our presenters. Guys, introduce yourselves.
Yeah, hi everyone. My name is Michael Vogt. I'm the aircraft performance engineer at ForeFlight, and I've been with ForeFlight since 2015.
And I'm Jordan Hovland. I'm the aircraft performance data manager. I've been here for a little over 5 years now.
And I'm Keith Wagner on the ForeFlight marketing team. Before we begin, I want to mention that you can ask questions using the Q&A panel. We have a team standing by to answer your questions, and we will also take a few of the more popular questions that come in and ask them to our presenters at the end. We tend to get a lot of questions towards the end of the webinar, so if you have a question, I encourage you to submit it as soon as you think of it. If your question is not answered during today's webinar, you can always send it to us at team@foreflight.com. Lastly, today's webinar is being recorded and will be available on our YouTube channel and website. With that, Jordan, take it away.
All right, thanks, Keith. Let's dive right into the landing factor workflow update in our recent release. We all know runway excursions are by far the leading safety issue in both the business and commercial aviation industry today. These runway excursions are often due to unstable or fast approaches. Besides correctly flying the approach through landing, a significant risk mitigation of runway excursions can be gained with the proper landing factor selection, initially during pre-flight planning using forecasted weather, and later during the in-flight phase using actual weather. The choice of a runway selection with a landing factor can be confusing to pilots. This is not surprising given that these selections are often a function of the aircraft's available published performance data, the certification basis of that aircraft, and the type of flight operation itself, such as Part 91, 91K, 135, or 125 operations. Michael and I are going to work through 4 different examples showing how our updated landing factor workflow provides a pilot the framework to help with selecting the correct landing factor and runway surface condition. Before we get to the examples, though, Michael is going to briefly mention a few references and resources worth reading on this topic.
Thank you, Jordan. So the first resource I want to talk about is the FAA's AC 91-79 Bravo, with the title of Aircraft Landing Performance and Runway Excursion Mitigation. This AC contains the latest FAA guidance and recommendations on the operational landing distance calculations, and it was updated in the summer of 2023. Chapters 2 and 3 of this AC specifically cover landing distance assessment before takeoff, also known as dispatch requirements, but also the time of arrival landing distance assessment. And as you will see in the examples that we'll show in a little bit, we have introduced a phase of flight concept allowing pre-flight or dispatch landing distance calculations, as well as in-flight or landing distance at time of arrival assessments. In Europe, the latter is referred to as LDTA, landing distance at time of arrival, and it is required landing distance assessment if the weather or runway conditions deteriorated from the conditions used during the pre-flight landing distance assessment. So we have chosen to use the LDTA abbreviation in in-flight landing distance calculations within the app, as you will see. I highly recommend reading this AC. It is really chock full of good information on aircraft landing performance calculations. The second resource is the Global Action Plan for the Prevention of Runway Excursions. This is an initiative by the Flight Safety Foundation and is in cooperation with several other industry stakeholders. The plan document offers recommendations and guidance across a truly wide swath of topics related to runway excursions, including landing distance assessments, weather effects on those, and much more. Finally, a third resource that I recommend reading is the RCAM, or the Runway Condition Assessment Matrix, which outlines the runway condition codes, also known as RCC or RWYCC. These runway condition codes are typically found in NOTAMs for specific runways when a runway is anything other than dry. They indicate a runway's braking deceleration ability. So for example, an RCC value of 6 corresponds to a dry runway with normal braking deceleration, whereas an RCC value of 1 corresponds to an icy runway with significantly reduced braking deceleration. Later on in the examples, we're going to take a look at where to find these RCC values within ForeFlight so that you can find that data and make your appropriate RCC selections. Another resource that I came across was one published by the IATA. It's called the RCAM and Runway Condition Report, published in 2021. Simply throw this into your favorite search engine and you will find it goes into great detail on how the RCAM system works, how the runway condition codes are meant to be interpreted. Okay, with the resource suggestions out of the way, let's dive right into example number 1. Example number 1 is what I'm considering a default example. Imagine we are a Part 135 operator in the United States and we are flying a Phenom 300 from Kansas to Miami Opa-locka Executive. What I see here is my landing page, and on this page here we have surface condition and landing factor and this new badge that indicates we are preparing a pre-flight or dispatch time of phase calculation. So I can tap on either surface condition or landing factor and it takes me into the new workflow to calculate our landing distance. At the top, we have our familiar header. We have our actual landing weight that we were planning on landing at. We have our landing distance calculation, and we have our LDA, our landing distance available. And as always, we show our maximum landing weight, what it is, and what its constraint is. In this case, we are structurally weight limited. A new item is this phase of flight selection. As previously mentioned, the phase of flight selection allows an operator to calculate landing distance either during a dispatch time or pre-flight before takeoff, or during an in-flight time or landing distance at time of arrival. So we have not taken off yet. We are doing our pre-flight or dispatch time of phase or phase of flight calculation here. And because we're a 135 operator, we need to take the unfactored dry AFM published distance and apply a 60% factor to that distance. In other words, we want to ensure that we stop on 60% of the landing distance available. Within ForeFlight, every single, within the surface condition list that you see here, the very first entry, the dry entry, will always be an unfactored dry AFM distance. That is taken care of by us for all aircraft. So we select that and then we scroll down to our landing distance factor group here. So within this group, we have options for 80% factored as well as 60% factored. Now in this case, we are forecasting a dry runway, no rain showers in the area, so we will go with a 60% factored selection or a 1.67. In the header, we see our factored landing distance is now calculated to about 3,700 feet, which is well below the 4,300 feet LDA that we have. We also noticed that our maximum landing weight has been decreased to 16,700 pounds, and the reason is we are runway limited. So with these calculations done, we can now back out and we can see the 1.67 factor is applied to the dry unfactored AFM distance. And we can also see that we have this badge here, the pre-flight dispatch badge, showing us that this is a case where we're doing our dispatch planning. Finally, if you go into the upper right here on the summary page, you can select the summary page and it's going to show you right here that we have our pre-flight dispatch time of flight calculations with our numbers over here and the 1.67 factor. So the nice thing is you can then add it to your flight's files and essentially retain that for bookkeeping purposes, showing that you've done this pre-flight calculation. So now we're in flight. We normally, if conditions do not deteriorate during your flight, you do not need to recalculate this, but let's assume they have deteriorated. Let's assume a rain shower passed over the runway, one of those heavy tropical rain showers that Florida is known for, and it created now a wet runway situation for us. So we would go back into our surface condition or landing factor selection, and we are in flight. So we toggle our in-flight selection up here, in-flight LDTA, and we are presented for this aircraft with a list of runway condition codes, RWICCs. As previously mentioned, a condition code of 6 indicates a dry runway, but we have a wet runway, which is condition code 5. So we now can select our runway condition code 5, which always has to be incremented by 15% safety factor. So you can see down here, there is no way to unfactor this. 50% safety factor is always given with our runway condition code. What we now see up here in our factored landing distance, it calculates it at 3,840 feet, which is still well below our 4,300 LDA. So we are good to land under this scenario, even with a wet runway. Now, I want to go back to point out one particular interest about this particular aircraft here. So the Phenom 300 publishes, or I should say Embraer publishes additional factored distances within their AFM. And some manufacturers do that. Some manufacturers will provide additional factored distances which may or may not adhere to the standard 1.67, 1.92 that we are familiar with. If you ever see an option with the word factored, that is your indication that the aircraft itself, or the FM itself, has factored distances built in. So if you select an item with a factored in the name, you will definitely want to select no additional factor. Otherwise, you will be double factoring the distance, which is very safe, obviously, but you're kind of penalizing yourself as well. So if you are authorized to use the OEM factor distances, which may or may not correspond to the standard 1.67, 1.92 for 60%, or 1.25, 1.44 for 80%, then you want to make sure you select the factored option with no additional factor, so you're not double factoring yourself. And we can see up here now the factored distance is right at 4,000 feet, which is still well below 4,300 for the LDA. So that concludes example number 1, which I'm calling my default Part 135, maybe Part 91K operations. And actually, before we move on to example number 2, I do want to point out where to find the RCC values within ForeFlight. So I prepared a slide here, and it's kind of hard to find some interesting RCC values. I prepared a slide here that shows where you might find these RCC, these runway condition code values within ForeFlight. Typically, they would be in the NOTAMs. So you can go to the NOTAMs on maps, or you can go to the NOTAMs for the airports on the flights page, and you can find those FICONs. They're called FICONs within the United States, field condition reports, but you can find these RCC values there in the NOTAMs for the airport itself. Airports that support digital ATIS will also include them in the digital ATIS when necessary. So what you're looking for is a group of 3 numbers, 555, 444, sometimes you see like a 433. And when you read up on your RCC codes and what they mean, it's basically looking at thirds of the runway, the first third, the middle third, and the last third, indicating what the surface condition is like in terms of from a braking perspective. So there are different places you can find these RCC values within ForeFlight. Now let's move on to example number 2. Example number 2 builds upon example number 1, but shows a few different things going on with this particular aircraft. So if I back out here, or actually I'll just switch over to my Demo 2 setup here. This is the exact same flight into Miami Opa-locka, but now we're using a Citation CJ3. So the Citation CJ3, if I go into landing here, and we have the same scenario, tap into here. The Citation CJ3, it has a couple of peculiarities about it. So the first one I want to point out is under LDTA. So if I tap over to LDTA and onto condition code, we get this screen. It says runway condition codes are currently not available for this aircraft. And we're asking you, the user, the customer, to select the actual surface condition instead. So this is a case where the manufacturer has not yet provided RCC performance, and you have to use the AFM values given. So in this case, we have our typical AFM values that we will find in the AFM. And if I scroll down here, we will have our factor selections that we can apply. Now, for an LDTA or a landing distance assessment at time of arrival, you must always increment it by at least 15% safety factor. In this case, you would probably want to use the actual surface condition that is reported. So if you have a wet runway, you want to select wet. If you have a certain depth of standing water, you want to use that. But then at least increase it by 15%. Now the other thing is, let me go back into here. Let's go to our dispatch pre-flight time here. So if you note, I have the unfactored dry AFM distance selected, and when I scroll down here, I have all my factors available, 80% and 60%. But as soon as I select wet or contaminated and look at my factor list, they're all gone. My factor distances of 80 and 60% are removed. We chose to do this on purpose because During the dispatch time of landing distance planning, it is not normal, it's not usual to select a wet or contaminated distance and then factor that in addition with an 80% or a 60%. If you go back to that AC 91-79 Bravo, it will instruct you to select your dry, unfactored landing distance as the basis for your factoring down here. However, we have learned that there are operators, there are individual pilots who have created their own SOP essentially that will select a wet or contaminated condition, and then on top of that, put an 80% factor, sometimes even a 60% factor on there. We did not want to take that away from them, so we kind of made it difficult initially to do that, but it's a very simple one-time change to your aircraft. So if I back out here into the aircraft, I'm going to select my CJ3 here, and if I filter on it, we're doing a demo 2, there's my CJ3. I'm going to tap on the edit button. So now I'm on my aircraft tail essentially here, and I can scroll to the field performance selection under performance. This is where I set all my default values for this particular aircraft. So every time I create a new flight, these default values that I have chosen here will show up. Now, with this release here, we have 2 new default items at the very bottom. This one down here, show percent factors for wet contaminated, it is defaulted to no. Users who want to select a wet or contaminated condition and pair that with an 80% or a 60% factor will want to change this to yes. Then those factors come back and become available. The other item that we added here was this displayed landing factors. So we received feedback that there are operators who always use 60%. They do not want to see 80% factor option, and vice versa. So you can do that here. So if I'm an individual operating a CJ3 and I always want to see just 80% factor because I will always put an 80% factor on whatever service condition I have, then I want to select show 80% factor only. I can even go a step further and make that my default. So this landing factor selection here is where I set my default landing factor. So in this case, we will assume I'm always incrementing it by 25%. So I choose my 80% factored here. Now going back to my flight, I go into landing and I select my surface condition here on my pre-flight page that I'm at right now. So I have my dry, unfactored AFM distance selected, and we see right away the 60% option is gone. I have my 80% factor option here, but now also if I change this to a wet condition, I still have my 80% factor here. So this gives the user some flexibility to bring those factors back for a wet or contaminated distance or surface condition if they need to do so. And with that, I'm going to wrap up example number 2 and hand it off to Jordan, who has some more interesting examples to share.
All right, thanks, Michael. For my first demo that I'm going to do, the demo 3 here, I wanted to highlight some peculiarities for the SO aircraft that they follow the same logic and implementation, but there are some nuances to it. So for this example, I have my demo 3 aircraft set up, which is a Falcon 7X. I will go into the landing view. I'll select my runway as normal. And then we will come into the surface condition and landing factor selector, and we'll see the list that we're used to seeing on the other demo aircraft. However, on the phase of flight, we have pre-flight and dispatch selected. And now I'm going to scroll down to the bottom of the surface condition options. And you'll see that we have runway CC codes of 1 through 4 also populated on here. The reason why we have that is, I'm actually going to switch to the Documents tab real quick. So on the Documents tab here, I have the Falcon 7X AFM loaded, and we're looking at Annex 10, Annex 9, which is essentially the nomenclature for Dassault's supplements. And this annex in particular provides data for landing distance assessment at time of dispatch on contaminated runways. And if I zoom in here a bit, we'll see that there's published performance charts for RCC codes of 1 through 4. that are specifically to be used during time of dispatch. There's also a Annex 10, which specifies the landing distance at time of arrival, and this annex publishes data for RCC codes of 1 through 6. So there can sometimes be differences in the result between these two annexes, and which is why we specifically have the capability to add these RCC codes under the dispatch pre-flight tab. And you'll see that coincides. We have the RCC 1 through 4, which is Annex 9. And then if I switch the phase of flight to in-flight or LDTA, we now filter out the RCC codes, but it's also specifically linked to that Annex 10 for the landing distance at time of assessment. So if you do calculations, comparison calculations between those two, you'll see that there are a little bit difference in the result that you'll get. Okay, and for the last demo, we actually have a slightly different aircraft to show you. It's going to be a turboprop. We're going to use the PC-12 NGX model as an example here. And before I actually dive into that demo, I want to go into the aircraft tab first to show the different defaults that we have. So we have those same two new selections at the very bottom in the default section. But for the displayed distance factors, we have another option available. And that's going to be the 70% factor, which is common for turboprops. And so you can see that we have the 80%, 70%, and 60%, as well as a combination of these different factors, or you could show all of them, or you could show none of them. For this demo, we'll just say we want to use the 70% factor only. Okay, so now if I go into the flight tab for the demo, we will follow our normal process here of going into the landing view. And then the UI is a little bit different than a jet aircraft, but it should be consistent with what you're used to seeing. We have our runway contaminant line for your surface condition selection. And then towards the bottom here, we also have our safety distance factor that you would normally enter. But you'll see now that this badge is being displayed for where we saw previously on the jets, it was under the landing factor. We have it under the safety distance factor. So it should be what you're used to seeing now. So we could tap either into the safety distance factor or the runway contaminant, and we'll enter into this new view. So if I scroll down to the pre-flight dispatch calculation or phase of flight tab, I'll scroll down to the bottom, and you can see now that we have these 70% factors available. And similarly, on the in-flight LDTA view, we have the RCC codes available as well, and we're showing the total distance up here in the header. All right, that concludes our landing factor selector demo. What I'd like to go into now is to show our new told card functionality. So first, I'm going to go into our Demo 3 aircraft, the Falcon 7X, and I can access the new told card either via the takeoff or the landing button, depending on which phase of flight you're in. So if I go into the takeoff tab, for example, you're used to seeing our summary report button here. And actually, if I go into that, just as a quick refresher, it provides a lot of information to the operator or to the pilot, a lot of the inputs and outputs for takeoff and landing, as well as a max takeoff and max landing weight analysis across multiple temperatures, runways, and engine out procedures. So this can be very cumbersome to navigate through at a quick glance of, okay, what are the numbers that I care about for the specific runway that I'm looking at? So if I go back, we took that feedback and implemented the told card up here, which is right next to the summary button. And what this view is a stripped version of our summary report, essentially. It's the results for, the runway you're taking off out of. In the upper left-hand corner, you can see we have our weather information. We have our engine out procedure and runway selected here, as well as some runway details. And then on the left-hand middle side here, we have all of our inputs. And then in kind of the central area, we have the information for our estimated or our actual takeoff weight, our max takeoff weight, and the limitation, as well as what surface we have selected, and then the V speeds, the takeoff field length, our N1 power settings, level off altitude, and then some climb gradient information for this one engine inoperative gradient here. So one thing that's unique about this view for the Falcon is that since it's a tri-engine jet, the outside or the side engines, they're a little bit different in terms of power settings than the center engine. So we can see here that we see the TO N1, that is going to be our side engine value first, and then in parentheses, we have the center engine as well. So just a little bit unique implementation there that you won't see on, the twin engine jets. Below here, towards the bottom, we also have our engine out details, which will give you a textual description of the engine out procedure. And at the very bottom, we display what the AFM revision is, as well as the aircraft data version is, which is what our current model is at. And then towards the bottom right-hand side, we have a badge that displays when this was the told view was viewed and based off of what weather report. Okay, and now before I go into the landing portion of the told card, I'm actually going to go into the takeoff card for the Phenom 300 first. And I'm actually going to do a weight and balance calculation so that I can get the takeoff CG value here. And then I will navigate back up to our takeoff button. And we'll see here that we now have the takeoff trim value. And this is another value that we include in the told card. And you'll see that up below the runway details here. And so the Falcon 7X doesn't have a trim setting, so I wanted to specifically call this out for aircraft that do have trim. We also include that in the told card. Okay, and I'll use the Phenom 300 for the landing card as well. So I'll go back to the destination landing button. And now I'll hit the told card here. And we can see that in this case, we're doing a LDTA calculation. So our surface condition is RCC 5 with a 1.15 factor. And what we have here is the actual distance that we're publishing. So the RCC code with a factor of 1.0, as well as the factor distance. So the RCC 5 multiplied by 1.15. If I go back and do a different type of calculation, such as a pre-flight dispatch, so we'll do a dry and 1.67 here. We'll navigate back to the told card, and we'll see that it's the same functionality. We have the actual distance and the factor distance. However, if I do a dry unfactored calculation, I will navigate back and we will see that we don't calculate a factor distance because we haven't performed a factored distance calculation. And with that, that concludes our landing factor selector and told card demos. Back to you, Keith.
Excellent. Thank you so much, guys. And before we get to everyone's questions that you've sent in, I wanted to point out a couple of useful links to you. First, ForeFlight.com/business is where you can learn more about everything offered in ForeFlight for business, including many of the things we didn't have time to cover today. You can also check out ForeFlight.com/webinars. There you can watch some of our past webinars, including those on dispatch, runway analysis, and much more. And lastly, we mentioned to reach out to our team at sales@foreflight.com, and you can reach out to our success team as well as our pilot support team by emailing team@foreflight.com. With that, let's move on to some of your questions. Michael, first, 2 questions are for you. The first one is emergency return available on the told card?
Yeah, thanks, Keith. I can just demo this real quick on my iPad if that works for you. So a couple of questions about the told card. The first one was about emergency return. And another very common question we have been getting since the release is, can we have the takeoff and the landing told cards on one single document, essentially? So I'm here on a flight here. If I tap on the takeoff button and scroll down to my emergency return section here, I can tap on that and then do my calculations. And you note there is no told button up here. But if you go back one level for the takeoff, you have your ordinary takeoff told button on here and you tap on that. What you will get is you will get a combined emergency return plus takeoff told card in one document here. And as always, you can send that to the flights files as well. In terms of combining the takeoff and the landing documents into one, that is some feedback we received since release, and we are actively looking at doing that so that you have all told cards in a single document to share with your flights files.
Excellent. That's great information to know. And next question is for Jordan. Will landing factor selections be implemented into dispatch on the website?
Yeah, good question, Keith. Thanks. So the functionality that we had previously to this update in ForeFlight Mobile was really the same functionality that we had on dispatch. A lot of the issues that we were seeing with the factor choice were coming from pilots in the cockpit operating both the dispatch calculations if they were doing a pre-flight calculation, as well as if they were in flight. We didn't specify or separate which are choices that are more geared towards a dispatch calculation or the RCC for LDTA. So for this first iteration, we decided only to implement the change on mobile, and we're kind of taking feedback here on how this implementation goes, and then taking that feedback to see how we can improve our dispatch side. Because there are some operations that need to do kind of that comparison calculation for doing just a dry times 1.67, but also having to compare to that LDTA calculation in case there's a scenario where the LDTA calculation ends up being kind of the limiting factor there. So we're looking into it, but we don't have any set designs or firm date to release at the moment.
And another question for you, Jordan. If you're flying and you get a last-minute runway change, how do pilots rapidly check that they are also good on the new runway?
Yeah, so it's fairly simple. Our aircraft performance engine, as well as the aircraft model that we have built, is all local on your ForeFlight device downloaded. So you don't have to be connected to the internet or anything like that. All you have to do is, it's literally as simple as switching the runway you want to choose to, and then ensuring that your aircraft configuration is appropriate for the scenario in which you're in. You can, change the weather conditions as well. If you're not connected to internet and don't have like a Sentry device or anything, you can just update all that manually by hand, and it's super simple.
With that, I want to say thank you to you both for taking the time to be here today, and as well as the ForeFlight staff working behind the scenes to bring this webinar to life and answer everyone's written questions. And lastly, I want to thank everyone for joining today's webinar. This webinar was recorded and will be available on our website and YouTube channel within the next 24 hours. And if you have any other questions about landing factor, refactor, about your operation, you can always email team@foreflight.com. Stay tuned for future webinars and updates to ForeFlight. And until next time, safe and happy flying, everyone.